This screencast is designed to help you begin to learn to translate situations involving mathematics into actual mathematical equations and expressions, and also use the properties of equality to solve equations. Let's cover some important vocabulary to get us started. First of all, an open sentence is a mathematical sentence that contains two or more variables. An equation is a special type of mathematical sentence stating that two expressions are equal to each other. A solution is a very special situation where the value of the variable or variables that are in the sentence and equation make it true. Very often we need to translate words and phrases into mathematical statements and sentences. And this is something for mathaids.com that is helpful, I think, in organizing that. So we have addition, subtraction, multiplication, division, things that involve equals or parentheses or grouping words, all of which help us organize and translate verbal words, written words into mathematics. So I'm not going to go over all of this, but this is a great way, I think, to organize a lot of these words that you're going to see. Now, this is by no means all of them, but these are certainly some of the most common that you're going to see. So let's do a little bit of translation here. Let's write an algebraic expression to represent the verbal expression 7 less than a number. So less than implies subtraction. So 7 less than some number means we're going to assign a variable to the number. Let's just call it n, but we could call it anything we want. And this number is going to be 7 less than that n. So the answer, the algebraic expression, is n minus 7. So we had to go back and think less than, okay, that means subtraction. Let's look at another example. An algebraic expression to represent the verbal expression, the square of a number decreased by the product of 5 and the number. Okay, so what we have here, we got to kind of break this up and move from left to right. Well, the square of a number, that means some number squared to the second power. And then we're going to decrease by, so then we're going to subtract. And finally, we have the product of 5 and that same number. Okay, so now we're multiplying product. Our answer to this, we have the x squared minus the decrease by the product of 5 and that number, 5x. Okay, let's look at some important properties of equality. This is going to be critical in our ability to solve equations using these properties. So we have 4 different properties. The reflexive property, I think about a reflection, looking in the mirror at yourself. So for any real number, a equals a. For example, b plus 12 is equal to b plus 12. Seems obvious, but it comes into play sometimes. The symmetric property. So if two things are symmetric, that means on either side they are the same. So for two numbers given by a and b, if a equals b, then the symmetric property says that of equality says that b equals a. So for example, if 18 equals negative 2 times n plus 4, then negative 2 times n plus 4 is also equal to 18. We can switch those around. The transitive property for 3 numbers, a, b, and c, given by 3 different values, if a is equal to b, and then b is equal to c, then since those two things, a and c, are both equal to b, therefore, A equals C. Very important property, the transitive property. And here's an example over here. So, if we have this first thing, 5 times P plus 3 equal to 48. And if we know that 48 is also on its own equal to 7P minus 15, then that first thing and that last thing, 5P plus 3, must be equal to 7P minus 15 as well. And then finally, we have the substitution property of equality, which states that if A equals B, then A may be replaced by B and B may be replaced by A. In other words, we can substitute B for A and A for B, just like in a recipe. If it says you may substitute margarine for butter, then you can put in margarine anywhere the recipe says butter, and vice versa. These next sets of properties are absolutely critical in being able to solve equations through algebra. Let's look at the addition and subtraction properties of equality. And it states that if for any real numbers, a, b, and c, if a is equal to b, if we're given that as being true, and then we add a quantity c to both sides of that equation, both the a side and the b side, then that still remains an equation that is true. So in other words, adding c to both sides does not change the equation. That also works for subtraction. We can actually take a and b and subtract a number c from it without changing the truth of the equation. That's absolutely critical, and here's why. Let's say we have an equation x minus 6 is equal to 14. Well, if we were to add 6 to both the x minus 6 side of the equation and the 14 side of the equation, we don't change it. But what we do wind up doing is isolating the x, because negative 6 plus 6 will cancel itself out. But what this addition property says is that adding the 6 to both sides does not change the truth of the equation. In a similar way, if n plus 5 is equal to negative 32, then we can actually subtract 5 from the n plus 5 and subtract 5 from the negative 32 and still have a true statement. So we have n plus 5 minus 5, which will cancel each other out, equals negative 32 minus 5. A similar thing is true for both multiplication and division. This is one of the things that makes algebra possible. So if we have, again, three numbers a, b, and c, as long as c is not equal to 0, because we can't divide by 0, if a equals b, again, then we can multiply both the a side and the b side by a quantity c and not change the truth of the equation. A times c equals b times c. The same is true for division. So if we have a number a and a number b and we divide them both by c on either side of the equation, it's still true if it was true before. So just looking at a couple of examples, if I have a quantity m divided by 8, and that equals negative 7, then I can multiply the m divided by 8 and multiply the negative 7 by 8, and it's still true. And what you're going to find as we solve these is the 8's cancel each other out on this left side, which is really isolating that variable is our goal. And so a similar thing for division. If negative 2y is equal to 12, that's kind of like our a and b terms. Then if we take the negative 2y and divide it by negative 2, and we take the 12 and divide it by negative 2, we still have a true statement, but the advantage is the next step would be we're going to cancel those negative 2's out on the left-hand side. We get y equals negative 6. So let's look at solving an equation using these properties of equality. So I have a variable m minus 5.48 is equal to 0.02. I'm given that. And we want to find that variable m that makes this true, because it says find the solution or solve. So we're finding the value of m that makes this a true statement. So we're going to use the addition property of equality, because if m minus 5.48 is 0.02 and we add 5.48 to both sides, what happens is negative 5.48 plus 5.48 cancel each other out. And that leaves us with m as equal to 5.5. You need to check your work. Make sure that value of m is correct, a correct solution to this. And so always take that answer and put it back in the original equation to determine if it's a true statement. So I'm going to take 5.5 minus 5.48. I'm using the substitution property here as I check my work. I'm substituting 5.5 for m because they are the same thing. And what I should get when I do that is 0.02, and indeed I do. That's checking your work. Always an important thing to do. Very rarely in the world, unless we're in some sort of a math contest, very rarely do we have to race through to an answer. You should always check your work. So what we've done in this screencast is put you on the road to solving equations by first being able to translate words and situations into expressions and equations, then using the properties of equality to begin to solve them.